Okay. Recall that the half-life of a medication is the amount of time for half of the drug to be eliminated from the body. So if you started with 1 gram initially at time t equals 0, you count the time, you check the time until you have just half of a gram in your body. Then you ask, at what time do I still have half? This time, we call it the half-life. So the time that it takes for half of the drug to leave your body. And in this question, they look at the half-life of Advil, and they give you the equation that will allow you to compute it. So notice that in this equation, it's an exponential function to start with because the variable t is in the exponent. And notice that the base here is 1/2 to the power half. So this you can write it as 400 times 1/2 to the power half, which is radical. You can do 1 over radical 2 to the power t. That you can write it like this. And 1 over radical 2, this number, let's see if it's bigger or less than 1. Of course, it looks like it's less than 1, but I want to show you that it's about 0.707. So this is 400 times, approximately this is 0.707 to the power t. Notice this is a number less than 1, and so this is exponential decay. So good. We know that this is an exponential decay, and why is it given like this and not in terms of E? This will be revealed in this question. And at the end also I ask you to write it in terms of E, to see it as in our natural exponential function. So now we solve it one by one. Okay, start from the beginning. First, notice that R is the remaining amount. That's why they use the letter R, because of how much is remaining from Advil in your body in milligrams. Okay, for example, this photo shows you Advil 400 milligrams. These are the tablets that they're talking about. So you take one of these tablets and then it follows this equation. So and the time is given in hours. For this medicine, the half-life is measured in hours. And you know that because probably you took this medicine before, or Panadol. The effect of it doesn't stay for a long time, between 2 to 4 hours. Then after you start feeling that the medication is wearing off. Okay, so this is just an introduction. Let's now solve the question. So part A, what is the initial dose? Meaning at time, initial means time t equals 0. So you just have to substitute 0 for t in the formula. And let's first put this around the formula, keep it here, and always you refer to it. I'll highlight it also. So let's see, R of 0 is 400 times half to the power 0 over 2. But any number to the power 0 is 1. And so the answer is 400 milligrams. That's the initial dose. Now part B, it asks you, how many milligrams of the medication will remain in the body after 5 hours? So this is t equal 5. What happens? How much is remaining R after 5 hours? This is how you do it. And you use the formula, 400 times half to the power 5 over 2, which is, and now we use the calculator, 400 times something to the power, let's raise it to the power 5 over 2, and then I'll put the half here. So 1/2 equals, yeah, so approximately, let's say, because this is approximate, I'm going to approximate it, 70.71 milligrams. So you started 400 milligrams was in your body initially, and then after 5 hours, when they computed how much is remaining, it was only 70 milligrams. So more than 75% of the drug left your body already. And that's why you start feeling that the effects of Advil are wearing off. So now let's go to part C. how many milligrams of the medication will remain in the body 12 hours later. So now they're asking you, put T equal 12 and check. So actually, I'll just go here and put 12 and see. Yeah, so you will say R of 12. We substitute 12 for T in the formula, half to the 12 over 2. And so when we use the calculator, we get not approximately, actually, this is exactly 6.25. I'm not approximating, milligrams, which is almost nothing. So after 12 hours, almost nothing is left in your body. Like this will not give you any effects. It will remain in your body, but it will go away very quickly. So this is why after 12 hours, there is no feeling of any medication in your body. Because, you know, from 400 milligrams, you drop down to 6.25 in your body. Okay. So the question now, part D, what is the half-life of Advil? So half-life, it means the amount of time to be half of the initial. So remember, initial amount was 400. So we are saying we need to find the time T so that if I replace T in R, I will get 200. Because 200 milligrams is the half the amount. But R of T is 400 times half to the T over 2. And so all what you have to do is solve this equation. So if we divide by 200, we'll get, divide by 400 both sides, you'll get 1/2 equals 1/2 to the T over 2. Very nice. This is like 1/2 to the power 1. And so this means that T over 2 is 1, because half to a power equals half to another power. They must be equal, the powers. And it means that T equals 2, but T is measured in hours. So the half-life is 2 hours. This is the half-life. And how do we make sure? Go back to here, and instead of 12, we'll keep it as 2 hours. And look, if you say after 2 hours, how much is left in your body? Equal 200 milligrams. So the half-life is 2 hours. Now I want to show you an easier way to do it. If you look here, you notice that half-life, they told you here that the half-life of Advil is represented by this equation. Why did they say it's represented by this equation? Because actually, when they put half as the base, they're trying to make it easier for you to find the half-life. Because notice, this is the initial dose, always. It will be the number here, and then this is half to a power. So you say, when this power equals 1, if you can make this power equal 1, then it will not affect the half anymore, and so you'll get half of 400, and that will give me my 200. You see? So this is very convenient when you're solving a question on half-life to have it written this way. So you're only asking, when can I make this equal 1? Asking like this. So it's when T equals to 2. Because if T equals to 2, look what happens. You'll put 2 here, and 2 over 2 is 1, and half to the power 1 is half. So imagine like this is not there, and then you'll multiply half by 400. That is much easier than solving it the way that I did here, but I had to show you that if you didn't notice what I just said about why this is good for computing half-life, this is a good formula for computing half-life. Okay, so even if they give you, for example, if they tell you R of T, let's see this. They said 400 times 1/2, let's say to the T over 3. Then, and you want to see what is the half-life of this, just make T over 3 equal 1, which means just make T equal 3. And you will notice that if you have here 3 instead, and the T that you wanted was there, then you put just 3 for T, and you'll get the half-life correctly. Okay, you see, hopefully you got, now you understood it. And finally, we just want to go to the last part and write the equation star, which is our equation here, using the natural exponential, this e, the e number. Okay, so r of t is what? It's 400 times half to the t over 2. So I want to write it as e to a power. Okay, so in this case, all what we have to do is see 400 is on both sides, so we need to see this is 1/2 to the power 1/2, all of it to the t. Notice this is 400 times 1/2 to the 1/2 to the t, because power the powers multiply. When you have power over power, they multiply. That's how you got t over 2. But why did I write it like this? Because now you can say this is 400 times an easier way, 1 over radical 2t equals, now look at the right hand side here, 400 e to the minus kt. Now look at how I will write it, e to the minus k, all of it to the power t. So that you see that in order for things to work, in order to find this k, 400 and 400 cancel, and you just have to make sure that 1 over radical 2 equals e to the minus k. So take ln of both sides. Ln of 1 over radical 2 equals ln of e to the minus k, which is minus k. And finally, so this means that k is minus ln of 1 over radical 2. But you can even simplify it further by saying this is minus, and you know, ln of 1 over something is ln of 1 minus ln of radical 2. And ln 1 is 0. And so this, you have the minus and the minus plus. So this becomes ln radical 2, and ln of radical 2 is equal to ln of 2 to the half, which is half ln 2. Okay, half ln 2 is much better than saying ln radical 2. Okay, so we can say that now we found k. K is half ln 2. So you go back here and you say this is 400 e to the minus k, which is half ln 2 times t. Okay, now just to check that what we did is correct, I'm going to check that the answers that we get from both formulas are the same. So I will just go now to the, if you want to actually find k as a decimal, because sometimes they tell you if you find it here, then also write it as a decimal, half ln 2. So let's see, what is half ln 2? Ln of 2 equals 0.34, yeah, approximately 0.3466 if you want to 4 digits. So, yeah, 5, 7, so after the 5 there is a 7, so you make it 6, approximately 3466. But let's keep it as half ln 2 because we can. Okay, so let's see, 400 e to the power of minus half ln 2, so half ln 2 times t. And now we will put the t to check. So remember, we want to see that all of them agree. So is it true that if I put 0 here, do I get 400 like this? Yes. Now, if I put 5, let's put 5 for t here. Do we get 70.71? Yes, nice. And let's put 12 and see, do we get 6.25? So let's here put 12. 6.25, perfect. And if we put 2, after 2 hours, we should get 200 milligrams left. Perfect. And so you see, this is the way to write it in terms of E. But I think you appreciate writing it like this because this makes it easier to compute the half-life. But this one is, you know, the natural exponential decay function. This is like, some people prefer to always write things in terms of E. And I will stop here.